Hello, my name is Jeff Resch, and this talk is part of the 5 Minutes with Python series. In this brief talk, I'll provide a comprehensive survey of the capabilities of the enhanced interactive shell known as IPython. If it looks like something you might want to investigate further, there is a follow-up talk entitled A Demonstration of the IPython Interactive Shell that gets more into the details using an interactive demonstration. In this talk, I'll define what IPython is, why you might want to use it, and generally, what mechanisms it adds to the interactive prompt. I'll cover the introspection capabilities it gives you, how it provides seamless access to the commands of your system shell, and integrates with your choice of text editors, allowing you to work in an iterative fashion. And I'll talk about how IPython can be hooked into your own programs, the execution profiling it offers, and how you can add extra information to your tracebacks. I'll conclude with where to get IPython and what resources are available in that community. IPython is an alternative to the default Python shell, increasing your effectiveness at the interactive prompt while retaining its familiarity and keyboard friendliness. Like the default shell, it is a text-based, non-GUI method of interaction. However, it does have good support to run side by side with various 2D and 3D data plotting libraries and GUI toolkits. IPython runs on all the popular operating systems, and it is free software, so you can use it everywhere. It can easily be invoked from within your programs, either explicitly to put you into an interactive environment with the variable namespace current at that point, or upon occurrence of an uncaught exception. These features make IPython useful for both debugging and for those blended types of programs with heavy computation intermixed with exploration of the results, as in scientific data visualization. IPython gives you the ability to powerfully introspect an object, showing its docstring, call signature, online help pages, or source code. You can enter system commands, change directories, and edit source files while remaining within IPython. This is especially nice for those platforms that lack a good command line shell. IPython has what are called magic commands, which provide high-level functions that control the behavior of IPython itself. You can define your own such commands, or in combination with an input filtering capability of IPython, construct a command language specific to the problem domain at hand. IPython is friendly to those of us who are particular to our text editors, moving source seamlessly back and forth between the editor and IPython while not forcing the use of a specific IDE text editor. At the prompt, IPython caches your most recent inputs along with the output they generated. This command history is easily viewed, logged to a file, and selectively saved into source files. You can bring selected portions into your editor and have changes re-evaluated into your session, and you can quickly convert groups of frequently used commands into named macros. IPython, like the default Python shell, gives you access to the interactive namespace for manipulating variables. However, it also provides easy ways to filter and display groups of variables and to reset the namespace to its startup state. Because IPython accepts magic and system commands, as well as source code, IPython uses rules to decide how to interpret a name when entered. If there's a variable with that name, it displays its value. Otherwise, it consults a registry of magic commands, essentially special names that invoke functions that manipulate your IPython session, navigate directories, and manage files. And last, it looks up the name and a list of aliases that map to commands issued to the underlying system shell. IPython gives you a number of ways to quickly look up information, almost eliminating the need to keep reference manuals at hand. The input history and variable namespaces are fully searchable by wildcard and type of object. IPython provides extensive tab completion features, expanding names into variables, directories, and file names. It understands nested namespaces and that you can type partial expressions like classname.tab and have it display the methods and attributes available to you. And you can query an object for information about its type, the namespace in which it is located, the source file from which it was loaded, and its docstring. You can also display the source fragment that defined it and its call signature if the object was callable. Arbitrary system commands can be entered by prefacing them with the exclamation or bang symbol as a common shell escape mechanism. Commands, perhaps with default arguments, can be aliased to a simple name for easier use. Command output, optionally split on line breaks or spaces, can be collected into Python variables. And in turn, variables can be substituted into commands. The system shell mechanism for IPython comes with a rich set of directory navigation commands with bookmarking, history, and a pushdown stack of frequently visited places. This makes working with complex frameworks across directory trees much easier. And you can cause arbitrary Python expressions to be executed in background threads. And with the extended version of IPython, called IPython 1, can be distributed across multiple CPU cores or host machines. IPython is line-oriented. While you can scroll back and change, rerun in previous inputs, that would be awkward for definitions of functions or classes. IPython provides a magic edit command that invokes your text editor on various kinds of targets. Upon saving and exiting from your editor, the source is re-evaluated into the current interactive namespace. You can pass to edit the name of a file you wish to change, but you can also pass an object reference. IPython will look up the source file from which it came, invoke your editor on that file, and position you at the definition. And you can pass the line numbers of previous inputs as a range or list, and their text will be loaded together into your editor. Upon exit, each line will be re-evaluated into the current namespace. We've all made a quick change in our editor only to find out at runtime that we've made a trivial syntax error. IPython, upon reloading your source after an edit, can detect that syntax error and automatically take you back into the editor at the point it occurred. IPython also provides a lightweight form of version control over edits. By retaining an historical copy of the result of each command, including edits, you can pass in an input line number representing a previous state, letting you revise and reload from that point. Quite useful when teaching or demonstrating. IPython provides ways to instrument your source with useful diagnostics. You can put calls in your program to start up an interactive session, giving you access to the variable namespace at that point. You can set IPython to enter the Python debugger upon the occurrence of an uncaught exception, letting you walk the stack frame and query variables. You can measure the CPU or wall clock execution time of code fragments, or run your code under the Python profiler for more detailed measurements. And you can set your preferred display of Python tracebacks, colorized for readability and with an extended mode of execution that shows more information. IPython is a mature, exciting project with a strong community. It has active mailing lists, separate for users and maintainers. A complete manual is available for browsing online or as a PDF document. And it has a tracking system for bug reports and feature requests. The project website provides magazine articles, video tutorials, and slide presentations. I recommend you check it out. There are other aspects of IPython I have not covered, usage tips and techniques, along with contributed extensions and profiles. Thanks for listening, and look for the longer talk that demonstrates the actual use of IPython. These slides and script are available under the Creative Commons Attribute Share Alike license, so you can use them in your own presentations. Thank you.